Good morning. Good morning, students. Yeah. So we were talking about basic concepts of chemistry, right? Okay. Now, with respect to the last class, can any one of you tell me what we have discussed in the last class? You can put words, some words, what we have discussed in the last class. Can any one of you? You can just type the words, what we have discussed in the last class. Okay, so types of mixtures, very good. So we have discussed about mixtures, very good. Then, okay, very good. Then we have discussed about matter. Yes, very good. Then, okay, Shreya, it is homogeneous, heterogeneous mixtures. Fine. So we have discussed about homogeneous and heterogeneous mixture. Yes, they are nothing but types of matters only, no doubt. Right? So that's where we have the mixtures, different types of mixtures, homogeneous and heterogeneous mixtures. So with respect to the matters, what are matters? Which are having their own mass and volume, right? So that one we will consider it as a matter. So where we have two categories, mixtures, and another category of matters will be, yes, Stephen, you are absolutely right. Okay, yes, it will be pure mixture and pure form, right? So in that case, if I take mixture, we have written, then when it comes to pure form, what we have discussed in the last class? When it comes to pure form, which are those categories which we have discussed in the last class? Any one of you? Yes, very good. So that is elements. Yes, that can be elements, where it can be a single element, that is atom, or it can be more than one atom, same type of atom, which will combine together to form the molecules, right? Yes, all of you correct. Then we have discussed, means we have not discussed in detail, but we had written about the compound. All of you will agree? So that's what we have discussed in the last class. Then along with that we have discussed about SI unit of mass, SI unit of volume. So no need to worry. We will discuss that one in detail in today's class. Okay? So this is related to yesterday's class, what and all we have discussed. Okay? Now in that case, we had left over with one of the concept that is related to compounds, because yesterday we have discussed about the molecules. Now we have to discuss about the compounds. Okay, so plural I have written, even you can write compound. Now can any one of you give the example for molecules? Any one of you, just type the molecule, that's all. Examples for molecules, any one of you can just type the examples for molecules. Oh, very good. So it is Ullas, very good. Oxygen molecule, that is O2. Oxygen atom is O, right? Okay, Yagnesh and Sushila Sanjay. Okay. So, water, they are not the example for molecule. So, don't get confused. Hydrogen, yes, Stephen, you are right. Hydrogen molecule H2 can be an example. O2 can be an example. But H2O is not a molecule. I'll come to that. Don't get confused. Okay? So, what I mean to tell you is, to avoid the confusion, I will write molecules also. Compounds here, molecules here. Okay? So now, in general, wait, Rakesh, I will come to that. Okay? So when it comes to molecules, these are the elements. These are the elements made of more than one atoms or elements of atoms. In general, that will be the definition for the molecules. Okay? Now, when it comes to the compounds, we can write it as, these are the elements or substance. These are the elements or substance which are made of more than one different types of elements. More than one different types of elements, or you can simply write it as, they are made up of different types of atoms or elements. Anything is fine. So that's where we have the definition for the compounds. So generally, molecules will consider it as, these are the molecules, these are the substance which are made up of more than one element or more than one atom, right? Here, these are the substance which are made up of more than one different types of atoms or elements. All of you will agree? So that's where I have the definition for the molecules and compounds. Now, yesterday I gave the example for molecule as O2. Yes, more than one atom is present. Two oxygen atoms coming together to form the oxygen molecule, that is O2. More than one hydrogen atom combined together to form the hydrogen molecule. So that's where I had given the example. If you observe it carefully, in both the cases, same type atoms are combined together. Same type of atoms are combined together. Fine. Now, when it comes to compound, I will give the example as water, H2O. When it comes to the compound, I will give the example as water, H2O. Then some of you had written ammonia, that is NH3. I will include that one in compound. Okay? Same way, I will add glucose, that is C6H12O6, an organic compound. So that's where I have the examples for the compounds. Fine? Yes, Ignish. Yes, even we can include sulfuric acid, that is H2SO4. And a number of examples we can give for both. Fine? So if you see the difference, in case of the molecules, we have the same. Why the elements come together to form a molecule? Okay, good question. Anyway, you will get the answer for this in detail in chemical bonding. Now for time being, I can tell that, yes, they will combine together to attain the stability. They will combine together to attain the stability. In detail, you are going to discuss these things in your chemical bonding topic, but very good question. Got my point? So his question was, why oxygen? Why can't it keep as oxygen atom? Why they have to combine? Right? way. Why two hydrogen and one oxygen, they should combine to form the water? Let it be like that. But that will not happen because this oxygen atom wants to attain the stability. This oxygen atom also wants to attain the stability. So to attain the stability, they will interact with each other. So that's where there will be formation of a molecule or a compound. Fine. So that should be the answer. But another thing here is, for example, if they would have not combined together, we would have not existed on this earth. We would have not existed on this earth. Stability can be got by forming a compound as well. But why molecule? Yes, even by forming a molecule, it will attain the stability. Even by forming a molecule, it will attain the stability. So therefore, both the type of elements are present in the nature. We have compound also, we have molecule also. Got my point? So both the types are there. So that's where we have the compounds and molecules which are present in the nature. Okay? Now, if elements will start telling, oh, I will not combine with same element, I will go with other type of element only, then we would have not existed only, because we are living on the oxygen gas. And oxygen, if it tells, no, I am not going to combine with another oxygen, I want other element only, then oxygen would have not existed in the nature. Then nitrogen gas, N2, would have not existed in the nature. But to have this stability, to have the stable ecosystem, nature has designed in such a way that both the type of elements will be present, compound also, molecule also. Got my point? Now, sorry Appa, while answering this one, I didn't tell. Yes, carbon dioxide, whatever Ullas has given, Pragati, it is a compound. No doubt, it is a compound. No doubt. Okay, carbon dioxide is a compound. So what I mean to tell you is, whether I have reached your question, Rishi, whether your doubt is clear. So that's where we have the compound and molecules. But basic reason for their existence is to attain the stability. That's all. Okay. Now I can tell that compounds are those elements or those substances which will be made up of more than one type of atoms. Which will be made up of one type of atoms. Whether it can be more than two or it will be two, whatever it is. If you observe here, hydrogen and oxygen, two different types of elements. Ammonia, nitrogen and hydrogen, two different types of elements. Glucose, carbon, hydrogen and oxygen, three different types of elements. So sulfuric acid, hydrogen, sulfur and oxygen. So three different types of elements. So therefore it's not compulsory that, I will come to that one, Pragati. So it's not compulsory that only two different types of elements should be there. No, it can be three also. Sometimes it can be four also. So compulsion here is it should be more than one type of different types of elements should be involved. That's all. Okay. Now why can't be a molecule, sir, since it is made up of more than one atom? Okay. So once again, that's what I mean to tell. When I am talking about molecules, we have assumed that these are the elements which will be having same type of atoms. Compound means these are the elements which will be made up of different types of atoms. Now, while telling, don't get confused. So while telling, see for example, if anyone is teaching chemistry to you or while reading chemistry textbook, you will find that they will be mentioning glucose molecule. They will be mentioning water molecule. Nowhere they will be writing glucose compound, water compound, right? So they will mention it as a molecule only. So sometimes this molecule will be used as a umbrella term. It can be used as a umbrella term. That means in a broad sense, any compound or any substance which are made up of more than one element can be considered as a molecule. It can be same type of element or it can be different types of element. So what I mean to tell here is all the compound should be a molecule, but all the molecule may not be a compound. Whether I am clear? All the compound should be a molecule because they will be made up of more than one type of atoms. But all the molecules may not be a compound because for a compound it specifies that it should be different types of elements only. Whether I am clear? Fine. So we cannot call this one as a compound. We cannot call this one as a compound. But we can call this as a molecule. Ammonia molecule. Glucose molecule. So therefore if you see the definition, so these are the elements which are made up of more than one atoms. I never mentioned different types of or same type of atoms. Okay? But generally we will assume that those molecules or those substances where same type of elements are there, that will be considered as a molecule. So those type of substance where different types of elements are present as compound. That's all. But while using the terminology, we will call glucose also as a molecule, water also as a molecule, carbon dioxide also as a molecule, even oxygen also as a molecule. So whether I am clear? All of you have understood? Any doubt in this? But compound compulsion should be more than one type of atom should be there. No other way around. No other options. Okay? But molecule, it can be anything which will be having more than one atom or more than one element. It can be same type of element or different types of element. But to be specific, they will consider molecules are those which will be having same type of atoms. But while using the terms, they will call molecule as a general term. Glucose also they will call it as a molecule. Even carbon dioxide molecule, no textbook they will mention glucose compound will be taken. They will be mentioning it as glucose molecule has been taken. Okay? Fine. So in that case, we will move to the next one. These are the some of the examples. Pure form of the matters. Okay? Now you might be having questions, sir, how compounds can be a pure form? Because there are two different atoms or more than two different atoms which are involved in the formation of a compound. How they can be considered as a pure form of matters? That will be the question. Right? Now when I am talking about mixtures, please remember that when I am talking about the mixtures, I told we have salt plus water. Right? Now they can be separated. They can be separated from each other. They can be separated from each other. Some of the physical techniques, some of the physical methods, by using that one, they can be separated. I took the example of preparation of table salt. I took the name of the place also, right? So where just by the evaporation, okay, so they are going to separate these things. Yes, sublimation only for some of the compound, not for everything. Okay, Yagnesh? But generally, this one if you take, it will be done by the evaporation. When you expose them to the temperature, water will get evaporated, salt will remain at the place, in the vessel. That's where salt and water will be separated. No chemical reaction they have used. No cleavage of the bond, nothing, just evaporation. That is a physical method. But if I take a compound if I take a compound, for example, water if I take, now you might be having a question, sir, this should be a mixture only, sir, because there is a oxygen, there is a hydrogen. No, they are not mixtures, because this water is made in such a way that there is a presence of covalent bond between oxygen and two hydrogen. Anyway, in detail, why this shape, everything you are going to discuss in your chemical bonding topic. But for time being, you remember that there is a presence of covalent bond between these two hydrogen with the oxygen. Now, if I want to separate hydrogen plus oxygen, then it's not possible just by the physical method. By evaporation, not possible. By boiling the mixture, not possible. So we have to go for chemical method where we have to cleave this particular bond. That's where compound and mixtures, they differ from each other. Compounds and mixtures, they differ from each other. Therefore, it is a pure form of the matter only. But it's not a pure form. All of you will agree? Understood? Say for example, I have a water. I have kept it for boiling because now so many pandemic and all is going on, COVID and all. So I want to use water which is proper one. That means which cannot cause any problem to my health. So what I will do is I will boil the water and I will drink. So in that case, if when I am boiling the water, some of the water molecule will be escaped as vapors, right? But rest of them will be present as a liquid water only, which we are going to drink. Now, if that is the case, if at that temperature, if this bond would have cleaved, then there is no water which will be left over in the vessel. Everything would have become hydrogen atom, oxygen atom. But that will not happen. Even if you boil the water, it will remain as H2O only. Fine? So that's where mixtures and compounds differs from each other. Okay? So compounds are pure form of matters only. Okay? So in that case, if I want to define or if I want to differentiate between mixture and compounds, if I want to differentiate between mixtures and compound, right? If I want to differentiate between these two, then I can tell that these composition can be separated by physical methods. Can be separated by physical methods like evaporation. It's a process actually, evaporation or distillation, right? By all this method, they can be separated. But here, only chemical methods, only by chemical methods or by cleaving the bond, composition can be separated or elements can be separated. Elements can be separated. That's where we have the difference. Composition means I am talking about the elements, individual atoms, whichever is there. So here composition means those individual molecules which are combined with each other. Okay? So what are those composition here? So here composition is nothing but molecules which are combined together. Here composition stands for atoms. Composition stands for atoms. That's where they differ from each other. Molecule, mixtures and compounds. All of you will agree? So due to that, this comes under mixture, impure form. That one comes under pure form of the matters. All of you have understood? Fine. Any doubts? If you have any doubts, you can ask. That's where we have the difference between compound and mixture. Okay. So in that case, we will move to the next one, that is related to properties. Properties of matters. Okay. So properties, which are those properties which will be shown by these matters? So in that case, I can tell that physical properties and another one is chemical properties. So we have two categories. When it comes to the properties of matter, we have two categories: physical properties and chemical properties. Okay, so these are the two properties. Now, physical properties means appearance. It's related to appearance. For example, what is that color which is present? That comes under physical properties. What is that texture? Anyway, all these things you are going to study in your salt analysis, chemistry practical. So what is that texture? Whether it is crystalline or amorphous, by touching those compounds you will feel. So that is based on the physical property. That comes under physical properties. Next, what is that melting point? If it is a crystal, what is that? At which particular temperature it's going to convert it into liquid form? That is melting point. So all this comes under physical properties, right? So that means to study all these things about a matter, there is no requirement of addition of some other molecule or compound. There is no requirement of addition of some other compound or molecule. Simply by observation we can tell. So therefore they comes under physical properties. But when it comes to chemical properties, it is based on the chemical reactions. It is based on the chemical reactions. Only by observation we cannot tell. We have to do the chemical reactions. We have to add some other thing to this. Then only we will come to know what is that chemical property shown by the matters. So therefore, all the matters in the nature will have both the type of properties, whether physical or chemical properties. Say for example, if I take sulfuric acid, H2SO4, if I take sulfuric acid, there is no label. We will imagine to that bottle there is no label. Okay? So it is sulfuric acid. But just by seeing that bottle, whether we can tell whether it is an acid or a base? No. We have to do some experiment. We have to do some reactions. Then only we can tell that yes, it is an acidic solution, whatever is that present in the bottle. Now, whether it is a liquid or gas, whether we can tell by just observation? Yes, that one we can tell. That comes under physical properties. Got my point? This one I just took an example. I have a bottle where sulfuric acid is there, which I know, students will not be knowing, and I will tell, just find out whether it is acidic or basic. Whether immediately will tell, no sir, it is basic. No, it's not possible. We have to check. What is that condition? We have to see reactions. Then only we can tell that it is acidic in nature and it is a sulfuric acid. Now I will tell whether it is a liquid or solid, find out. Then you are going to do the same thing? No, just by observation you will tell that it is a liquid. So that is the difference between physical properties and chemical properties. All of you have understood? In your chemistry practical, you have salt analysis. That will be the major one. So in that salt analysis, All these things you are going to study. One is physical properties and another one is chemical properties. So based on that you are going to tell that yes, this is the given salt. Okay, based on the chemical properties. Fine. All of you have understood? Any doubt? If you have doubts, you can ask. In that case, shall I move to the next one? Okay? Fine. So next one is related to mass and weight. Because these are the things you will come across very often. They will tell molecular mass, molecular weight. So in a day-to-day, this one, for our comfortable purpose, we will use mass and weight. Okay? Together sometimes. Molecular mass, molecular weight. Right? So that's where we have the mass and weight. Now we know that what do you mean by mass? Mass is nothing but amount of substance present in that particular matter. Right? So that is nothing but mass. It is nothing but amount of substance present in a matter. That is nothing but mass, a rough definition. If I want to go further, I can tell that it is amount of force required to give an acceleration to a particular matter, whatever it might be. That's where we have the mass. Naturally, it should be a constant. Whether I will take water molecule here on the earth or whether I will go to moon, everywhere it will be having 2 hydrogen, 1 oxygen only. It will not change. So therefore, mass will be a constant. It will be a constant for a particular matter. It cannot be changed. Right? Only for biological system it can be changed after few days. That's yesterday I took my example now for to explain the mass. For that moment it might be a constant, but after 1 month by strict diet, Raghavendra sir has reduced his mass. That is possible. But for non-living things, it's not possible. I'm not talking about mountains and all, trees once again living, but I'm not talking about mountains and all. I'm talking about these type of molecules or compounds where it cannot be changed. So mass is a constant. Okay? But when it comes to the weight, it is the force exerted due to the gravitational system or gravitational force. It is the amount of force exerted by the gravitational force. So therefore it can vary because here it is related to gravitational force. Here it is related to gravitational force. And all of us we know at earth and at moon there is a difference in the gravitational force. Weight can vary. At the same time, at sea level, if I go to the Mangalore and if I come to Kashmir, weight can variable. Okay? Ullas. So mass is nothing but that is the amount of substance present in a matter. To simply to tell that one, I have a vessel, I have a glass. Okay? So I have a glass of water. Okay? So now if I consider the mass of this, complete this one. Now I can tell that it includes this glass and number of water molecules present inside the glass. Altogether it will become mass. Right? Now if I have this one in Mysore and I will take it to Mangalore and I will be careful that there should not be any loss of water molecule. So I will go to the Mangalore, then I will go to the Kashmir. Whether any variation in the composition, number of water molecules will remain same. This glass vessel will remain same. So the mass will remain same wherever I go. But if I see with respect to the weight, which is related to gravitational force, then I can tell that at Mangalore it can show one value. If I take this one to Manali, top region, right, or Kashmir, Himalaya, top of the Himalaya it can have different value. To moon if I take, it will have the different value because gravitational force will vary. Gravitational force will change depending on the altitude. Depending on the altitude, gravitational force is going to change. So therefore, weight of this one is also varies, but mass will remain same. Mass cannot be changed. So therefore, due to this difference, SI unit for this one is kilogram, which we will mention it as kg, kilogram. For unit of weight is Newton, because it is related to gravitational force. So therefore it should be Newton for the weight. But generally whenever we are using mass, weight, we will mix it up. Okay? So mass and weight we will mix it up. But they are actually different terminology. All of you have understood? So that's where we have the mass and weight. Any doubts? Okay, therefore they have different SI unit also. Okay, any doubt in this? Okay, so next term, that is volume. Next one is volume. Even this term we will come across while reading chemistry textbook. Not only mass and weight, even we will come across volume very often. Yesterday only I took the example, a gas present inside a cube. We are going to talk about the volume. A liquid present in a vessel. We are going to talk about the volume. Right? So that's why we have the volume. Now generally we know that based on the equation, volume is nothing but density, volume is nothing but A cube. Volume is nothing but A cube. Okay. So that is nothing but 3 parameters we should take. Now that is one thing, volume. Same if I have a density. Density normally we will use it for liquids or even for all the other matters also we can use. When it comes to the density, we will tell that solids have higher density compared to liquid. General statement I am giving. Exceptional cases are there. Now what do you mean by density then? Density is nothing but mass by volume. So therefore, before coming to the density, I wanted to talk about volume. Okay? So yes, Yagnesh, it is mass by volume. So mass we know. Volume we know. What should be the SI unit for volume density then? It should be kg per meter cube. Kg per meter cube. That should be the SI unit for the volume. Density. Because it is nothing but mass by volume. All of you have understood? Fine. Now, for example, in day-to-day life, we will be observing all these things. During Happy New Year this one, right? Or some of the festivals. I am talking about festivals like Christmas and all. Okay? So where 30, 90, 60, and you came to know what I am talking about, right? So to that we will be adding the ice. To that we will be adding the ice. Or lemon juice. During hot season, we are going to have the lemon juice or soda where ice will be added. What we will observe? Ice will be floating on the surface of the liquid. Ice will be floating on the surface of the liquid. That is because density of ice is less than that of the density of the water. Right? Same way, if I take coconut oil, if I add it to the water, what will happen? They are going to float on the surface of the water. That shows that density of coconut oil is less than that of the water. But if the same time if I take glycerol, glycerol is a molecule which will be used by the film actors for tears purpose, right? Glycerol is nothing but glycerin. So when I add that one to the water, it will not going to float, it will go to the bottom of the water. That shows that density of glycerol is greater than that of the water. Right? So what I mean to tell here is, if I take the example of ice and liquid water, ice and liquid water, both are made up of water only. Both are made up of water only. But still, density changes. Still, density is going to change. Right? What might be the reason? Naturally, since density and volume, they are inversely related. Try to understand this. Since density and mass, they are directly related. Now, as there is an increase in the mass, density is going to increase. As there is an increase in the volume, density is going to decrease. Got my point? As there is an increase in the mass, it leads to increase in the density. That's where they are directly related. Increase, increase. As there is an increase in volume, there will be decrease in the density. So inversely related. So increase, decrease. Got my point? Now if I take, you can observe at your home also, take a glass, okay, put some ice cubes into that. Put some ice cubes into that. Right? So this is the volume which will be occupied by these ice cubes. This is the volume. Okay? So there are some empty space. Naturally it should be there with respect to the empty space because we are talking about the cubes. Now, same thing when it will get melted. Same thing when it will get melted. Whether it will go for higher volume or lesser volume. Same number of ice cubes. If they are getting melted down, whether it will have same volume or it will be having higher volume or it will be having lower volume. You can just mention lower, higher or same. What will happen? Got my point? It's a simple experiment. I have a glass, I have kept some ice cubes into that glass and I will keep it at room temperature. Slowly it will melt down. Yagnesh is telling it will have lesser volume. It will have lesser volume. Okay, Stefan, even Shankar is telling less. So Prabhavati and Stefan, they are telling higher. Okay, equal. Democracy. What to do now? Equal, vote has become equal. Two less, two higher. Any other people who are giving the answer? Okay, less, lower. Okay. So we will go with the democracy because we are in India. So who is giving highest answer? Less, lesser one. No, don't go for higher. Lesser one. It will have the lesser volume. It will have the lesser volume. Therefore, in the beginning only I gave one hint by telling that there will be presence of empty space. Right? So therefore it will go for higher volume when it comes to ice cubes. But when it will get melted, when it will become liquid, it will go for lower volume. That's why, since lower volume for liquid, same mass is constant in both the case. Since volume has become less, density has increased. Since volume has become more, density has become less. So therefore, ice will be floating on the surface of the water. All of you have understood? Therefore, in the Antarctic region, biology students will be knowing this. In the Antarctic region, that's where we have aquatic organisms which will be alive. Because ice will be floating on the surface. At the bottom, liquid water will be there, where we have the fishes and all, which will be living very coolly. No need to worry. But the whole volume of water would have become ice. What will happen? No fish can be alive. That's where we should appreciate nature, right? That's where we should appreciate the nature. So beautifully it has been done. And so beautifully we can use that one for explaining the chemistry also. Everywhere chemistry is there, right? So that's what we can observe. Fine? So therefore ice will be floating on the surface of the water. Everything is based on the density. All of you have understood? Any doubt? Now I was expecting one question. Anyway, if someone would have observed, I told New Year celebration or Christmas time and all, I told 30, 60 and then I told 90, right? So don't think, oh sir, full practice. No, I have seen my friends and all, okay? Fine. So 30, 60, 90. What is that? I was talking about 30 ml, 60 ml and 90 ml, like that. It will goes on. What is this? Sir, you told volume something, A cube. That means meter cube you told, sir. That is volume. What the hell it is? 30 milliliter, 60 milliliter, 90 milliliter. ml means milliliter. Right? Now, whenever we are talking about liquids, normally we will express in liters. If you go to any shop, your mother has asked you to purchase or to bring some oil, coconut oil or sunflower oil. And you are going to the shop that and you are asking, give me 1 decimeter cube of oil. What will happen? Shop person will look at you like, angel. Who is this girl? Why she is talking like this? Right? So, but if you tell, give me 1 liter of coconut oil or 1 liter of sunflower oil, easily he will give the packet or he will give the oil. Right? But the same thing if you go with meter cube format, then he will look at you surprisingly. They will not understand. So therefore, whenever it comes to the liquid, normally we are going to express in terms of liters. Normally we are going to express in terms of liter. All of you got understood? Now, 1 liter symbol is L. 1 liter is nothing but 1 dm cube. 1 liter is nothing but 1 dm cube. Sir, what is that dm? Dm means decimeter cube. Dm means decimeter cube. I know you people are not understanding. Sir, which language you are talking, sir? So therefore, to understand this, you should know some of the conversion factors. You should know some of the conversion factors. See, for example, SI unit for the length is 1 meter, or it will be in meter I told. Fine. SI unit of length will be in meter I told. Fine. Now we should be having some terminologies. For example, there is 1 meter length cloth you should give me. If I am telling there is 1 meter, 2 meters, 3 meters, that means I am talking about the length. Right? Now, 1 meter, always I cannot use it in 1 meter because I have a very small thing. But I cannot go with meter, which will be a very large scale. I have to go with small scale. So conversion is required. If I take a cells, biology students, if I take a cell, the size of the cell itself will be in micrometers, nanometers and all, organelles. So how to express? So conversion factor. I will not go so much lower this one, don't worry. So 1 meter is nothing but 100 centimeter. 1 meter is nothing but 100 centimeter. Okay, so that's where we have the conversion factor. 1 meter is nothing but 100 centimeter, or I can tell vice versa. 100 centimeter is equal to 1 meter. Anything is fine. So 1 meter is equal to 100 centimeter, or 100 centimeter is equal to 1 meter. Now observe it carefully. 1 meter is equal to 10 to the power of 2 centimeter. Whether I am right? Or to be more appropriate, I can mention 1 into 10 to the power of 2 centimeter. Whether I am right? You can observe and you can tell me yes or no. So 1 meter is equal to 100 centimeter. Then I have written 1 meter is equal to 10 to the power of 2 centimeter. Then I have written 1 into 10 to the power of 2 centimeter. Fine? Okay, good. Now, why have I written 10 to the power of 2? Because 10 into 10 is nothing but 100. 10 into 10 is nothing but 100. Therefore, 10 to the power of 2. To be more specific, to be more accurate, I have mentioned it with respect to scientific notation. This is nothing but scientific notation where I am specifying there is a 1 multiplied by 10 to the power of 2. I am specifying. So this is a general one. This is very accurate one. Because in an urgency, I can tell that I can make a mistake. I would have written 1000, which will be a wrong one. Now to make very accurate, I will mention it as 10 to the power of 2. There is no question of addition of 1 0 or removal of 1 0 by mistake. Right? So that's where scientific notation plays the important role. Okay? All of you have understood? Now I have a question. Listen to me carefully. All of you have understood this one. Now I have a question. Can you tell me 1 centimeter is equal to how many meter then? 1 centimeter is equal to how many meter then? Any one of you? 1 meter is equal to 100 centimeter. Or I can mention 100 centimeter is equal to 1 meter. So small m can be the unit, symbolic representation for meter. Now 1 centimeter is equal to? Sir, very bad sir. No Rakesh, no Ullas, no. Observe it carefully. Once again I will write here 100 centimeter is equal to 1 meter. Now my question is, for 1 centimeter, how many meters will be there? Yes, Varun, you are absolutely correct. Very good. That's very simple. That's why I am telling how to convert. How to convert. Observe it carefully. Now I want for 1 centimeter, how many meter I want the answer, right? So what I will do? I will take for 100 centimeter, it is 1 meter. For 100 centimeter, all of you will agree? For 100 centimeter, it is 1 meter. How much for 1 centimeter? How much for 1 centimeter? So centimeter will get cancelled. Whatever answer comes, that is 1 by 100 meter. 1 by 100 meter. All of you will agree? That is nothing but 1 by 100 meter. Or I can mention this one as 1 by 10 to the power of 2 meter. Or I can mention this one as 10 to the power of minus 2 meter. Or I can mention this one as 0.01 meter. 0.01 meter. If you are not understanding, no need to hesitate, because all these things will help you in solving problems. In the exam, they may not ask directly, okay? But while solving the problems, it will help you out. All of you have understood? This is where we have to use the information which we know. What is that information we know? 100 centimeter is equal to 1 meter. That information we know. So now the question here is, how much for 1 centimeter, how many meters? So whichever we want to have the answer, that should be multiplied. Whichever we want to have the answer, that should be here. And whichever we know, it should be at the bottom. For 100 centimeter, we have 1 meter. How much for 1 centimeter? So naturally the unit for the answer will be meter, because centimeter will get cancelled. All of you will agree? So that's why it will be 0.01 meter. All of you have understood? Any doubts? If you have any doubts, let me know. How come, sir? How it became 10 to the power of minus 2? Because at the denominator it is written as 10 to the power of 2. If I take it into numerator, it will become minus 2. Right? So now, therefore, based on that, I can tell that 1 by 10 is nothing but 0.1. 1 by 100 naturally should be 0.01. It should be 0.01. That's what we have written. All of you have understood? Any doubts? All of you have understood? No doubt, right? Now, when I am talking about decimeter cube, decimeter cube, stands for divided by 10, Deci stands for divided by 10. Deca means 10. So deci means divided by 10 or 10 to the power of minus 1. Deci means 10 to the power of minus 1. Now, 1 ml, observe it carefully, 1 ml corresponds to 1 centimeter cube. 1 ml corresponds to 1 centimeter cube. Now, 1 liter corresponds to 1000 ml. 1 liter corresponds to 1000 ml. Now, in that case, how many centimeter cube in 1 liter? How many centimeter cube in 1 liter? 1 ml corresponds to 1 centimeter cube. 1 liter corresponds to 1000 ml. Then 1 liter corresponds to how many centimeter cube? Now how you are going to calculate? I have given the information, but I want 1 liter in terms of centimeter cube. I don't want in ml. I want you to convert them into centimeter cube, because SI unit for volume is meter cube, or it can be derivatives of meter, that is centimeter cube. How you are going to calculate? Yes, Yagnesh has given us 1000 centimeter cube. All of you will agree? So all of you will agree with that? Now what we have to identify? 1 liter corresponds to how many centimeter cube? That means whatever answer will come, that should be in terms of centimeter cube. Right? Yes, all of you are right. So what I will do is, I will use the information where 1 ml corresponds to 1 centimeter cube. 1 ml corresponds to 1 centimeter cube. 1000 ml corresponds to how many centimeter cube? Because whatever answer will come, it will be in centimeter cube. So naturally it will be 1000 centimeter cube. Fine, it will be 1000 centimeter cube. No need to worry. I will stop here. So what you can do is you can practice with different values. If you are finding any difficulty, let me know. I will explain. Okay. So that's how you are going to calculate. By using given information, you can calculate which has to be find out. Okay. All of you have understood? Any doubt? Any doubts in this? Whether I am clear? Any one of you, if you have not understood, let me know. I can explain it once again tomorrow. No need to worry. But whether it's clear, if you have any doubt, okay, fine, you can tell me. Yes. Stefan, some mistake you have done. 1 centimeter cube is equal to 1 ml. So 1 centimeter cube is equal to 1000. No. Something is there. Sir, please solve a problem on the concept of density. Yes, sure. We will solve some problems. Okay, no need to worry. We will solve some problems. Okay. So anyway, tomorrow once again I will explain this. Okay. Okay, bye. Take care then. Take care. Bye. Thank you. Yes, 1000 ml it should be Stefan. Okay. Now it's correct. Okay. Thank you.